Hello friends, welcome back. Hearty welcome to you. In this session, let's look at how to find out the derivative of inverse trigonometric functions. In the last session, we have seen how to find out the derivative of trigonometric functions. Now we will see how to find out the derivative of inverse trigonometric functions. So let's start here. I have listed down on the right side all the derivatives of inverse trigonometric functions. They are very simple proofs. We'll just go through them one by one and try to close it as quickly as possible. So y equal to sine inverse of x. So we have to find out the derivative of sine inverse x. So I took y equal to sine inverse x. We know that dy by dx is nothing but dx by dy whole to the power of minus 1 or 1 by dx by dy equal to dy by dx. So the meaning of that is, if you want to find out the derivative of a function, it's nothing but equal to 1 by derivative of inverse of the function. Okay. So let's start with y equal to sine inverse x. So we will say y equal to sine inverse x. Let me write it down. I will say y equal to sine inverse x. Now we know that we are talking about inverse functions, we are talking about bijections, and we already covered that in detail when we have gone through inverse trigonometric functions, but you can refer to that. So we know y equal to sine inverse x. I can write x equal to sine y because it's a bijection. X equal to sine y. Now I want dy by dx, but I know that if I find out dx by dy, I can do the inverse of that. Okay. So what is dx by dy? X is sine y, then dx by dy equal to d by dy of sine y. We know that sin x differentiation is cos x. I can write it as cos y. Therefore, we know we want actually dy by dx, but what we found is dx by dy. So I will say dy by dx equal to 1 by dx by dy, that's equal to 1 by cos y. But we know sin y is equal to x. Then what will be cos y? Cos y will be nothing but equal to square root of 1 minus x square. How we got it? Because we know sin square y plus cos square y equal to 1. That's one of the trigonometric Pythagorean identity we have. So if x equal to sin y, then cos y is square root of 1 minus x square. Therefore, the derivative of sin inverse x is nothing but 1 by square root of 1 minus x square. So the first one is done. Let's go to the next one. Now let us see how we can find out the derivative of cos inverse x. You can apply the same logic and you can do that, but I will prefer to do it in finish it in a simple way. I will say we know that sin inverse x plus cos inverse x equal to pi by 2. Will you agree with me? We have seen that when we have done inverse trigonometric functions. So can I write down cos inverse x equal to pi by 2 minus sin inverse x? Now we want to find out the derivative of cos inverse x. So can I say d by dx of cos inverse x is equal to d by dx of pi by 2 minus sin inverse x. But we know d by dx of pi by 2 is 0 minus d by dx of sin inverse x. D by dx of sin inverse x is nothing but 1 by square root of 1 minus x square. So d by dx of cos inverse x is minus 1 divided by square root of 1 minus x square. So if you know sin inverse x, cos inverse x is nothing but just multiply with 9 minus 1, because we know sin inverse x plus cos inverse x is a constant. So when you apply derivative of them, they both should add up to, derivatives of both of them should add up to 0. So derivative of cos inverse x will be minus of derivative of sin inverse x. Now let's look into tan inverse x. So let us see how to find out the derivative of tan inverse x. We have been given y equal to tan inverse x. We know x can take any values from real numbers r and we know that y values will be between minus pi by 2 to pi by 2, just to make sure that we have a bijection there. Okay, now y equal to tan inverse x, let me just write it down. I will say y equal to tan inverse x. That gives me x equal to tan y. Should be very easy to do that. Yes, if x equal to tan y, I will try to find out what is dx by dy, so that I can again do the reciprocal of that. So I will find out what is dx by dy. Dx by dy is nothing but derivative of tan y with respect to y. Now we know derivative of tan x. Tan x is secant square x. So this is secant square y, which is nothing but 1 plus tan square y. Why we are writing it? So that we can convert that into x square as needed. Now what is dy by dx? Dy by dx is equal to dx by dy whole to the power of minus 1. That's equal to 1 by 1 plus tan square y, which is equal to 1 by 1 plus tan y is x. So that is equal to 1 by 1 plus x square. So d by dx of tan inverse x is 1 by 1 plus x square. Now applying the same logic, that tan inverse x plus cot inverse x equal to pi by 2, you can see that d by dx of cot inverse x is minus 1 by 1 plus x square. How we know that? We know that because, let me write it somewhere with different color. Yeah, let me write it down here. Let me squeeze it in here. Tan inverse x plus cot inverse x equal to pi by 2. So can I write tan inverse x equal to pi by 2 minus cot inverse x? Now, or cot inverse x equal to pi by 2 minus tan inverse x. You know already the derivative of tan inverse x is 1 by 1 plus x square. Derivative of pi by 2, constant is 0. So you will have minus 1 by 1 plus x square. Or can I say derivative of tan inverse x plus cot inverse x is equal to 0. So derivative of cot inverse x is minus of derivative of tan inverse x. So that way you can prove that cot inverse x is minus 1 by 1 plus x square. Now let's look into what is the derivative of secant inverse x now. Let us see how to find out the derivative of secant inverse x. We know y equal to secant inverse x. So let's try to find out how I can write it in terms of x. Can I say x equal to secant of y? Then can I say dx by dy equal to secant y into tan y? Now what is secant y tan y? Nothing but secant y into square root of secant square y minus 1. How we got this? Because we know secant square theta minus tan square theta equal to 1. Therefore tan theta equal to square root of secant square theta minus 1. So we can do that. So what is dx by dy then? Dx by dy equal to secant y, that is nothing but x into square root of x square minus 1. So x value now can be less than minus 1 or can be greater than 1, because we see x is all the values of real numbers other than the whichever the interval we have between minus 1 and 1, including the boundaries. So x can be positive or x can be negative. It can be greater than 1 or it can be less than minus 1. That's why we keep it as a mod of x, absolute value, so that we can take care of that. So dy by dx will be nothing but equal to 1 by mod of x into square root of x square minus 1. Very simple. We know y equal to secant inverse x. You have to be very careful with the concept of when you can inverse them. That has to be very clear. If y equal to secant inverse x, I can write x equal to secant y provided this satisfies. This is the only interval where it is a bijection. That you have to be very clear. Now dx by dy, we know secant x derivative is secant x tan x. but tan x is square root of secant square x minus 1, so I get secant y into square root of secant square minus 1, or x into root of x square minus 1. X can be negative or positive because the real numbers other than minus 1 to 1. So it can be x can be less than minus 1 or x can be greater than 1. So there are two options I have. So if it is positive or negative, we will take both the values to take care of them. We will do mod of x. So dy by dx is 1 by mod of x into square root of x square minus 1. Now applying the same logic like what we did earlier, you can see very clearly that secant inverse x plus cosecant inverse x equal to pi by 2 again. So cosecant inverse x equal to pi by 2 minus secant inverse x, or when you apply derivative on both of them, you will see that derivative of cosecant inverse x is minus of whatever you got by for secant inverse x, that is it is minus 1 by mod of x into square root of x square minus 1. That's about derivative of inverse trigonometric functions. In the next session, we will see how to find out the derivative of hyperbolic functions. After that, we will see inverse hyperbolic. Yeah, we will go through that. After that, we are done with all the concepts and the formulas, so we can start doing the problems. Start with elementary level problems, then intermediate level problems, then really some brain teasers. Okay, so I'll catch you again in the next session. Thanks for your time. Bye for now.